The structure of the atom. Matter refers to anything in the universe that has mass and takes up space. The smallest unit of matter is an elementary particle. An elementary particle cannot be divided into any smaller parts. The components of an atom. The atom is the basic unit of matter. It is not an elementary particle, as it can be divided into smaller particles. The structure of an atom. The atom consists of a positively charged nucleus. The nucleus is an extremely dense region at the center of the atom. The nucleus is surrounded by a negatively charged cloud of electrons. Now, orbiting electrons represents a way certainly to understand what electrons are doing, but it is not exactly how it happens in reality. Reality itself is very, very strange. Inside the nucleus of an atom, the positively charged nucleus consists of particles called nucleons, which are protons, which are positively charged and are essential to any nucleus, and neutrons. Neutrons have no charge, and they serve as a buffer between protons. A little more about protons. Protons are subatomic particles. Protons have a positive charge, and protons are found in all atomic nuclei. The mass of a proton is 1.673 times 10 to the exponential minus 27 kilograms. This is equivalent to a very small amount of mass. Neutrons. Neutrons are also subatomic particles. Neutrons have zero net charge. Neutrons are found in all atomic nuclei except that of hydrogen, which in its most common isotope form has only one proton. The mass of a neutron is 1.675 times 10 to the exponential minus 27 kilograms. Again, this is equivalent to a very small amount of mass. Here is an example of a typical nucleus of an atom. The structure of an atom of helium showing the central nucleus consisting of 2 protons in red with a positive charge and 2 neutrons in grey with 0 charge. And there is also a surrounding cloud of 2 electrons in blue with a negative charge. Mass refers to the amount of matter in an object. The mass of electrons are only 1 over 1836 the mass of a nucleon, which is a proton or neutron. Because the mass of protons and neutrons are much larger than the mass of electrons that surround the nucleus, then the mass of an atom is almost entirely made up with the mass of the nucleus. This table gives some details on different properties of protons, neutrons, and electrons. And here is a hydrogen atom. The mass of a hydrogen atom is essentially only the mass of a single proton. Now, of course, there's no scale which can actually measure any mass this low. This scale is only here to give an idea that we are dealing with mass. An atomic mass unit. The atomic mass unit is used in the measurement of the mass of an atom. 1 AMU, or atomic mass unit, is equivalent to the average of the mass of a proton and a neutron under rest conditions. This works out, if we take the average of both of them, as 1 AMU equaling 1.674 times 10 to the exponential minus 27 kilograms. It's simply a mean of the mass of one neutron and one proton. And over here we have a helium atom. A helium atom consists of 2 protons and 2 neutrons. If we add all of those nucleons together, the 2 protons plus 2 neutrons, well, 2 plus 2, of course it equals 4. And the AMU units for a helium nucleus is the same, 4 AMUs. The role of protons in the nucleus. Protons have a positive charge of +1. If placed together, they will repel each other. Here we have a couple of animations. One is a depiction of the electromagnetic repulsion between positively charged protons through a ping-pong analogy. Now this is like the electromagnetic repulsion of like poles of a magnet. If you are to put 2 like poles of a magnet together, then they will repel each other. Looking at the role of neutrons in the nucleus. The neutrons have no net charge, and really they're there to keep the charges of the protons apart. If we had a nucleus consisting only of protons, it's likely that the protons would repel each other before they got close enough to actually bond and form a nucleus. So neutrons, having no charge, sit between those protons and allow everything to bond together to form a nucleus. The charge of the nucleus. Neutrons have no net charge, and protons have a positive charge. Well, this makes the overall nuclear charge, of course, positive. Remembering that this is the nuclear charge and not the charge of the atom, which we'll look at in a moment. The role of electrons in the atom. The nucleus is surrounded by a negatively charged cloud of electrons. The electrons are attracted to the positively charged nucleus by the electromagnetic force, just like magnets. Interactions between electrons, between different atoms, is where chemical behavior is observed, and we'll be looking at that in some detail in later videos. Balancing electrons in the atom. Here we have a stable atom, where it has the same number of electrons as protons. So in this case, the stable atom has 2 protons and 2 electrons, and the overall charge is 0. We also have an unstable atom, otherwise known as an ion, and that has a different number of electrons and protons. The unstable atom in this case has 2 protons and 1 electron, and as a result of this imbalance, its overall charge is +1. It has a positive charge. The volume of the atom. Even though the mass of the atom is predominantly contributed by the nucleus occupies a very small part of the volume of the atom. Most of the volume of an atom is actually taken up by electron clouds, where electrons are moving around. In fact, most of the volume of the atom is actually empty space. Although different atoms for different elements have different sizes, generally, the diameter of an atom is in the range of 1 to 5 times 10 to the exponential minus 10 meters, whereas the diameter of a typical nucleus is only about 10 to the exponential minus 15 meters. Thus, the nucleus is much, much smaller than the total volume of the atom. And now on to some fantastic facts. You and me and everything around us are made of atoms. And it's strange to think that, actually, we're almost entirely made up of empty space. If you'd like to know what constitutes the building blocks of a nucleus and some of the weird and wonderful things that can go on inside a nucleus, click on this video.